Okay, for this video, I want to talk about how to use the calculator to quickly calculate the answer given by Newton's method. So let's take a look at this problem on the practice 3 exam. Problem number 9. We want to use Newton's method to find all solutions of the equation correct to the 6 decimal places. Sine is equal to x squared minus 2. So what this question is asking is essentially where the sine and x squared minus 2 intersect. Well, we know how to draw the graph of sine, we know how to draw the graph for x squared minus 2, and well, there's the graph. We see that x squared minus 2 intersects sine at 2 locations, somewhere on the left, somewhere on the right. What this means is that this solution What this means is that this equation have 2 solutions. Now, instead of finding the intersection, let's convert this to a problem of finding roots. We'll just subtract everything on the right hand side to the left. And we get sine minus x squared plus 2. Let that be a new equation, call it f of x. Note that finding the point of intersection of sine equal to x squared minus 2, that is now the same as finding the solution to f of x equal to 0. So if we want to use Newton's method, we first have to find the derivative of f of x. Derivative of sine is cosine. Derivative of x squared, bring down the exponent and then minus 1, so it's going to be 2x. Now, Newton's method requires us to have an initial value, an initial guess. In this case, I'll just use my initial guess to be pi over 2. Of course, you can just choose any reasonable point that you want. For example, 1 is reasonable if you look at the graph, but 15 all the way out here is not going to be reasonable. So just pick something that's relatively close to the point that you want to find, the roots that you want to find. So then, now we have our x naught, then we put into Newton's method. X1 is going to be x naught minus f of x naught over, x1 is going to be x naught minus f of x naught over f prime of x naught. Right up there. And then x2, you take whatever the previous value you have is for x1 and you put it back into the recursive function to get x2. x3, you would use x2. To find x4, you would use x3 and so on and so forth. So how do you actually do this on the calculator? Let's see. So first, due to the fact that we are working with trig function, just make sure everything is in radian. Now, the first thing you want to do is to type in your initial value. So I'm going to type in pi divided by 2 and just click enter. What that does is that it's going to save this value into the memory as the previous answer. So now, how do you proceed? Well, you are going to type second answer minus open parenthesis, type in f of x. F of x is up there. So sine, instead of x, again, you type answer minus answer squared plus 2, close parenthesis, that's the numerator, divided by the denominator, which is f prime, cosine, answer, minus 2 times answer. And there you go. That's it. So answer, right now, what is located as answer? Your previous answer, meaning pi over 2. Right now, answer is the same as pi over 2. You click enter. That's going to give you x1. When you click enter, 1.7 is now automatically being put into the location of answer. So right now, everything in this equation is there where 1.7 is in the place of answer. What does all of that mean? If you want to find x2, just click enter again. x3, click enter again. x4, x5, x6, so on and so forth. You can do this for as many x as you like. In this case, the moment that we see that two of the value have the same 6 decimal, we stop because that's what they are asking for. They are asking for the solution up to 6 decimal places. And now, we do the same thing if we pick some point to the left, something close to the solution on the left-hand side. In this case, I choose pi over 2. Minus pi over 2. So I do the exact same thing. Minus pi over 2. Click enter. Again, just rewrite the entire function. Right there. Answer minus sine of answer minus answer squared, so on and so forth. And then we just click enter. We just click enter until we see the same number up to 6 decimal places. And there you go. That's the solution. Negative 1.0615498.